In this lab video, I'm going to go over the calculations for our Experiment 10 with Beyond Labs, Part 1. In this experiment, we reacted HCl in our beaker it's aqueous with NaOH from the burette. This is a double displacement reaction, right? So we think about we've got really H plus, Cl minus, Na plus, hydroxide, OH minus, our polyatomic ion. We're going to swap cations and anions, so sodium and chloride match up to make sodium chloride, 1-to-1 ratio, and H plus and OH match up to make water, HOH or H2O liquid. In part 1, we're doing practice titration. So you're given the molarity of both the base and the acid. We're supposed to do the calculations using the molarity of the base that's given and see if you calculate the correct molarity of the HCl. So in my experiment that I performed on Beyond Labs, I was given a molarity of 0.1104 for the NaOH and 0.1031 molar for the HCl. It's important to write these down. I performed my titration. I started with my burette exactly at 0.00. I saw my light pink color after a couple practice trials, so I did this a couple times and I got some good data with 23.35 milliliters. I would also add to your data table that this is indeed the numbers for the NaOH. Because that's what you're adding from the burette. So our goal now is to calculate the molarity of your HCl that was in your beaker. To calculate molarity, this is a 3-step process. 1, find moles, HCl. 2, find liters, HCl. 3, divide moles of HCl by liters of HCl to get molarity. So step 1, we start with the volume added of NaOH. So volume NaOH added always equals V final minus V initial. So that'll be 23.35 milliliters minus 0.00 milliliters. It's important to remember anytime we're using a burette, you have to have 2 digits past the decimal point, right? Because we can read to one little increment of 0.1 mil and you estimate 1 digit past that. So for my volume added, this is 23.35 because I started at 0. The solution map we're going to follow is convert from milliliters of NaOH added to liters NaOH added to moles NaOH added. Remember, our conversion from liters to moles is molarity. And then one more conversion to moles HCl. And this is our mole ratio from our balanced chemical equation. So I'm going to start with my 23.35 milliliters of NaOH. Remember, whatever units you start with need to go downstairs to cancel. So I can convert from milliliters to liters of NaOH using my metric system. So 1 liter I know contains 1,000 milliliters. I can then convert from liters to moles using molarity. So let's make a note of this. So we have 0.1104 molar NaOH, right, from this number here. That stands for moles of NaOH for every 1 liter of NaOH. That's a conversion factor. And I can see I'm starting with liters of NaOH, so that needs to go downstairs. I want to convert to moles of NaOH, so that goes upstairs. 1 liter contains 0.1104 moles. And now I convert from moles of NaOH to moles of HCl. So I'm starting with units of moles of NaOH, so that goes downstairs to cancel. I want to get to moles of HCl, so that goes upstairs. And now we need to use our mole ratio from the balanced chemical equation. Looking at my balanced chemical equation, there's no number in front of HCl, so that's a 1. NaOH, also no number, that's a 1 as well. So we have for every 1 mole of NaOH, I have 1 mole of HCl. And now let's double check that the units cancel. Milliliters of NaOH cancel, liters of NaOH cancel, moles of NaOH cancel. Left with moles of HCl, and that is indeed what I want. On my calculator, remember, we put this in, we go across, upstairs multiply, downstairs divide, multiply, divide, multiply, divide. Multiplying and dividing by 1 does nothing to the number, so we can ignore that. So on my calculator, I'm going to type in 23.35 divided by 1,000 times 0.1104. Enter. And we do indeed want 4 significant figures, right? We've got 4 sig figs there, unlimited for the metric system conversion, 4 sig figs here, and unlimited for my mole ratio. And I end up with 0.002577784 moles of HCl. So 1, 2, 3, 4 sig figs. I'm going to round at the end. That was step 1, getting my moles of HCl. Step 2, my liters of HCl. Well, if you remember from the lab, you used a 25 milliliter burette. So I had 25.00 milliliters of HCl. I need to convert that to liters, so I'm going to divide by 1,000, which results in 0.02500 liters of HCl. And again, 1, 2, 3, 4, keeping those 4 significant figures. Now step 3, my molarity of HCl is my moles over liters, 0.00257784. Last sig fig there is at 7 moles of HCl divided by 0.02500 liters. And now on my calculator, I still have that entire number for the moles of HCl, 0.00257784, because I converted to my liters of HCl. I did that math in my head. Or you can type in the moles again and divide it by 0.025, and I end up with 0.103136 moles over liters is capital M, HCl, rounding to 4 sig figs, 0.1031 molarity HCl. And looking at the given, so this was a practice titration, the actual molarity was 0.1031, so I was right on. Okay, so this is an example of how you can find the molarity of a solution that's in the beaker if you know the volume of the solution in the beaker and the volume added from the burette and the molarity of the solution in the burette as well.